What if I told you there was a guitar pedal that could do this? And this. And even a little bit of this. Now what if I told you that that same pedal was 100% open source? This is that pedal. Now this doesn't look like a do-it-yourself kind of pedal. In fact, it reminds me a lot of Chase Bliss style pedals with 6 knobs, stereo in, stereo out, and 2 foot switches, except instead of 3 switches across the front, it has a screen and a rotary encoder. It also has MIDI in and also MIDI out, so you can send messages through the pedal or use the pedal itself to generate MIDI messages to other devices. So a little while ago, the creator of this pedal reached out to me asking if I'd be interested in developing software for it, to which I said yes, and he sent me one of these, and I've recently been having a huge blast developing different modules for it and learning all kinds of new DSP tricks. Now, what does it mean to have open source hardware? Well, everything you see inside of here, the design files are freely available, and you can send those files off to a manufacturer and they will make it for you. And there's a little bit of soldering work that you have to do after that. And then this yellow chip here is what's called a DaisySeed, which is the sort of the brains of this pedal. A lot of you may be familiar with that. But it just plugs right into these headers. This is what it looks like. And it's a little $30 chip that you can order from a company called Electrosmith. And it just fits right into those headers. And that does all of the digital side of this pedal. The rest of this handles input and output, audio buffers, MIDI, power, foot switches, all that sort of thing that this pedal requires. So now I'm going to bring up the computer screen and give you just a surface level overview of this project and all of the relevant files. To get to it, you'll go to github.com. The name of the project is DaisySeedProjects by the user BK Shepherd. Now if you go to the main page and scroll down, you'll see a video demo that'll take you to YouTube, and then a lot of information on the hardware for these pedals. Oh, this is just one of the pedals that he has on this page. You can also do a pedal in a smaller enclosure without a OLED screen and 4 knobs, and he has 2 versions of that one. One uses the SMD, the smaller components on the board, and the other one uses through-hole components. But for now, I'll just stick to this one. So the project itself is split into hardware and software. So we'll look at the hardware just briefly and go to the 125B. That is this size enclosure. The other one is a 1590B, which is this size, which is a little bit smaller, a little bit thinner of an enclosure. So in the 125B, he has all of the updates that he's done to it, a bunch of detailed pictures. But if you actually want to build this, you'll go to this Build the Hardware link, and it goes step by step through the whole process of using the KiCad files and the Gerbers to manufacture this board, and then all of the other parts you'll need to assemble this and put it together. But to really understand this, I'm just going to download this, and we'll open up a few of the files and get an idea of what all's in here, because it's great to talk about it, but until you open this up and see what all's in it, it's hard to get a understanding of what's included if you're not familiar with this kind of thing. So what I did here is I clicked code and I'm downloading it. You can also clone the project, which is recommended if you're making your own modifications and things like that. But right now I just want to get the files and open them up and show you what they are. So now if I drill down into the project files and go to the 125B pedal, PCB, then I'll find all of the relevant KiCad files for the design of this pedal. And if you just want to order this pedal, you would go to the Gerbers and use those to send to the manufacturer to build. But I'm going to open up the design file itself. So it's the overall file is a KiCad Pro. And I'll go into the schematic first. This is how everything's laid out. It shows you all of the electrical connections, all of the components, and it's very well organized. This first page shows the DaisySeed and all of its connections. There's a section for power, audio inputs, outputs, MIDI in, true bypass relays, the screen, and the controls. And now I'll open this up in the PCB editor and you can see how it's all laid out. And I believe this is a 4-layer PCB. And you can tell a lot of thought went into designing this and the layout. Everything's really jammed in there. There's not a lot of wiggle room. And that's it. If you wanted to modify this, you could. You could create your own pedal based on this. Now, the other half of this project is the software, which is also open source. If I go into the software folder, guitar pedal, then we have all of the C++ files that can be compiled to run on this pedal. I'll just briefly touch on what each of these things are. The guitar pedal file is kind of your main file that everything else stems off of. At the top, you can include different effects, modules. It has the audio callback, so each cycle of audio that is processed comes through here. But if you're going to add your own modules, what you want to know is you need to include your module effect up here at the top, and then towards the middle, you're going to change the available effects count to add one or change how you want, and then add your effect, the name of it, right here. And under effects modules is where you would add your own unique effects. And the framework has made it pretty simple and intuitive to add an effect with a certain number of controls that are mapped to different knobs. And so it's been a lot of fun just coming up with ideas. It makes it really easy to prototype any kind of idea you can come up with for a new effect and try it out very quickly. So now that I've given you a brief overview, let's dive into this pedal and some of the sounds it can make. So for this module, I'm using what I'm calling a MidiPitch, and I'm singing into the microphone, which is going through the pedal, and then using the keyboard to shift the pitches and create different harmonies. So let's see how this goes. Hello, 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 hello. I'm finding it really hard to stay on one pitch. Hello, hello. So with this module, I can play up to 3 notes at a time. Here's 1, E, 2, E, and 3.